All right, let's continue. This is number 38. Number 38. It says, write an equation in standard form for the line described by -2, -3, and 0, and 0, 1 that are on the line. So they want us to write an equation in standard form. Be careful with this one. This one's a little tricky because they throw a little curve at the end. However, every time they ask us to write an equation, what is the first thing we write? Everyone. Y equals mx plus b. I circle my m because I need a slope, and I box my letter b because I need a y-intercept. Therefore, first thing I need is my slope. Do we know how to find a slope given 2 points? Yes, so I draw an arrow this way, and I write m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The second thing, very second thing I do is rewrite this blank, minus, and minus. Are we there so far? All right, so we need values here, which means I'm going to label my points. X sub 1, y sub 1, x sub 2, y sub 2. So let me begin with the numerator. What is y sub 2? Y sub 2 is 1. Y sub 1 is -3. Next, what is x sub 2? X sub 2 is 0, and x sub 1 is -2. Now, do you guys see why it's important to write the subtraction for each at the beginning? Yes, because here we have negative times a negative, which becomes a positive, and same thing right here, positive. So this becomes 4 over 2. So my slope is 4 divided by 2 is 2. So we write this one right here. But right now, since we're not graphing, I'm going to leave it as a whole number. Okay? All right, next. We need a y-intercept. Do we have a y-intercept? Are you sure?
Yes. No. Yes. No.
Look at this. Isn't this 0, 1 a y-intercept? Look at this one. 0 of x, 1 of y is my y-intercept. So do we need to do like the substituting of x and y? No. However, if you want to see it in action, here it goes. Look up, please. 0 of x, 1 of y. Bring everything else down. What is 2 times 0? 0. So we're left with 1 equals b. Now can we write an equation given that we have a y-intercept and a slope? Yeah, so let's write y equals, instead of m, what do we write? 2x plus 1. Okay, are we there so far? However, is this standard form? No, this is what? Slope-intercept form. Is that correct? So I want you to label this one right here on the side. Label this one slope-intercept form. Which means I need to do one more step so I can get at the end what? Standard form. And if you can remember, standard form is when we have the x and the y on the same side. So tell you never what I need to do to this equation to get. That is correct. So we subtract 2x, subtract 2x. So we're left with -2x plus y equals 1. Is this standard form? Yes. Now we are done. So be careful with this one, because a lot of you are going to want to do this. Look up. You're going to see, write an equation. You do all this, boom, 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 and then some of you are going to want to stop here. But that's not what they're asking for. They're not asking for slope-intercept form. They're asking for standard form. Yeah. Be nice. All right. Look up, everyone. Huh? Yeah, I'm gonna upload these. Really quick, recap. Look up forms. Slope, intercept. Everyone, when we hear slope intercept form, what do we write? Y equals mx plus b. What is the only other form that we've talked? Well, there's one more form that we talked about, which is y form, but right now it's part of slope intercept form. The other one is standard form, which is ax plus by equals c. Guys, focus. Oh my goodness. All right, so here we go. Slope intercept form, standard form. I'm going to write a couple of equations. You tell me if it's slope intercept or standard form. You don't have to copy these. Ready? Here we go. Just some practice. Look up, please. Example Q. Ready? 4x plus 3y equals 6. Tell you never what that is. Example super Q. Yes, this is standard form. How about there's 2y minus 6x equals 10. What is that? It's not standard form. Tell you never why it's not standard form. Which one needs to go first? X. So what can we do to change this? Using commutative property, we can move this one over here and this one over here. So standard form is what, everyone? Negative 6x plus 2y equals 10. Do we understand what we're doing now? Example mega Q. Look at this one. Y equals 10 minus 2x. Tell you remember what form that is. So is it standard form?
No.
Is it slope intercept form? No. The only form that we can think of is Y form. Yes? How can we change this to slope intercept form, everyone? Commutative property, move this one here and this one here. So my slope intercept form is Y equals negative 2x plus 10. We got this? Yes? Yes, Mr. Q. All right, good. All right, let me go to number 37. Let's go to 37. I'm going to zoom in. It says, find the slope of the line that goes through negative 2, 1, and 4, 3. Here it goes. Slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And when did we do this one? In the warm-up today, yes? So this is number 2 on the warm-up. So therefore, I'm not going to go over this one because I'm already going to upload the video of the warm-up from this morning. Okay? So let's go to number 36. Didn't we do this one too? Yes. This one was what number from the warm-up? Number 1. This was number 1 from the warm-up. I'm also going to upload that one once we're done here. Yes? Also, number 35, this was number 5 on the warm-up from today. All right, so we're done with those. Man, we're going pretty quick. Yeah. Number 34. Mike wrote the sequence 180, 190, 200, 210. And they want us to find the next 3 terms in the sequence. Before we find the terms, let's write our recursive rule. Look up, please. Here we go. Underline where it says recursive, because there's another one that looks very like it that says what? Explicit rule. Right now I'm going to go over recursive. Okay? Here we go. So let's first label how many terms they give us. They give us term number 1, 2, 3, 4. And they're asking us to find what? The next 3 terms. So we need number 5, 6, and 7. Well, first let's find the pattern. Let's see. What happens from here to here, from here to here, from here to here? Tell your neighbor, please. Everyone? Add 10. So you're going to write at the bottom plus 10. And what do we call that? Our D equals 10, our difference. So, is this a arithmetic or a geometric sequence? Allison. I thought you moved. It's because you are the sunshine. Really quick, look up. A quick recap. Look up. Here goes the two different formulas that we covered. We covered f of n equals, look up, f of n minus 1 plus b. And then we covered f of n equals f of n minus 1 times r. The first one, this one is arithmetic sequence. And this one is what? Geometric sequence. What does the D stand for? The D stands for difference. You guys remember that? Difference. That means if the sequence is adding or subtracting. The R stands for ratio. That means if the sequence is multiplying or dividing. So what is the sequence doing here? Audrey. What is it doing? Adding. So what kind of sequence is it? Arithmetic or geometric? Arithmetic. So we're going to write here our recursive rule. Here we go. F of n equals f of n minus 1 plus what? 10. That is correct. Is it coming back? Yes? Yes, Mr. Q, we love these. All right, here we go. So what does that mean? Recursive means, Nate, recursive means that in order to find number 5, I need which one? That is correct, the previous one, number 4. So check this out. Underneath here, let's find number 5. So we're going to write f of 5 equals f of 5 minus 1 plus 10. F of 5 equals f of, what is 5 minus 1? 4 plus 10. F of 5 equals, what is f of 4, everyone? What is our fourth term? 210. That goes right here. 210. Bring down the plus 10. So f of 5 is what? 220. So we're going to write that right here. 220. And we can do that just by thinking about it, right? 10, 10, 10. But we want to see the work. Yay. So we did this for f of 5. What do you need to do next? F of 6. Yay. F of 6 equals f of 6 minus 1 plus 10. F of 6 equals f of 5 plus 10. You guys remember this? F of 6 equals, what is f of 5, everyone? 220. So that goes right here. 220 plus 10. So f of 6 equals 230. And that goes right there. And what is the last one that we need to find? 7. So therefore, I'm going to let you do that computation by yourself so you can get some practice. Yay! Well, let me see.
Oh my God.
We're on number 34. Yeah, we're not on another number. 34. All right, let's see. Tell me what to write. Garrett, go. F of 7 equals. Continue, Yair. F of 7 equals. Plus 10. Thank you. Continue, Nate. F of 7 equals. What? $230 plus 10. And what was it, 230? Because f of 6 is what? 230. So f of 7 is 240. So my three terms are 220, 230, and 240. Piece of cake? Yes?
So confused.
Why? You were doing another problem?
No, no. Wait.
Be nice.
How did you get 230?
Right here? Hold on. Right here?
Yeah.
Okay, so watch.
Oh! It's different.
Now you saw it?
Yeah.
Okay. So every time, guys, here, we keep substituting. When we get to this part, we need to substitute what f of 4 is. What is f of 4? 210. What is f of 5? 220. And what is f of 6? 230. And that's how we get the following one. Okay? Let's go to number 33. It says, look up, please. For the relation 1, 3, negative 6, 2, 5, negative 6, and 1, negative 3, write the domain. What does that mean, Nate? What does domain mean? All what? That is correct. So let's look at all the x's. Here we go. X, 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 X. So we're going to write the domain in here. Okay? All right. So we're going to rewrite these, the domain, in ascending order. What is the smallest number? Negative 6, comma. 1, comma. Okay, here we go again. In ascending order, the domain without repeating. Which is the smallest one? Negative 6, and then 1, and then 5. And we're done, because we don't repeat numbers. Is that correct? What is our range now? This is a domain. Let's look at our range. What does range mean, Nate? The Y. That is correct. So, what is our range in ascending order? Go ahead, Rafa. Go. Negative 6, negative 3, 2, and 3. Bam. Rafa in the house. Thank you. All right. It says, is this relation a function? Ethan, is this relation a function? Manuel, is this relation a function? Denise, is this relation a function? No, because there's two x's that are the same. Which x's are the same? 1 and 1. They repeat. And if they repeat, the y's need to be the exact same number. Let's see. What is the y for this one? 3. What is the y for this one?
Negative.
Therefore, not a function. Why? The x value 1 repeats, and it has two different y values. 10u. Does that make sense? Yes. So the first part of checking to see if it's a function, you need to check to see if there's any x values that repeat. Can you know what I just said, please? The very first thing of blah, 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 blah is blah, 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 blah. Okay? All right. So, really quick, here goes a quick recap. Look up, please. So, here on the side, you don't have to write this. I'm going to check to see if you understand what functions are just by looking at points. Here we go. Ready? Look at this one. Look at this relation. 0, 1, 2, 3, negative 1, 5, and give me a number. 1, 9. Is that a function? Yes. Why? Because no x values repeat, and we can't really check to see if there's anything that has two output values. Everybody with me? All right. But as soon as we see this, look up. 0, 1, 2, 3, 1, 5, 1, 9. So you never why that one's not a function. Everyone, because the x value repeats, but they have a different what? Y value. Okay? All right, let's move on to number 32. Let's go to 32. Here we go. It says, graph the function 4x plus y equals 3 for the domain negative 1, 0, 1. Okay? So this is what I'm going to do with this one. To me, it's easier if we first change this to y form. So let me zoom in. Look up, please. So to change this to y form, line down the equal sign. And what do we do from there, Audrey? Yeah, here, help her out. Isolate the y, which means I need to do what? Subtract 4x, subtract 4x. We're left with y equals negative 4x plus 3. Now that we have that, let's get values of what? Negative 1, 0, and 1. That's our domain. So we're going to do this. X, y, negative 1, 0, and 1. So what's my first value that I'm going to substitute in there? For x, right? So this is negative 1. Bring down the rest. Y equals negative 4 plus 3. What is negative 4 times negative 1? 4 plus 3? 7. That goes right there. What's our next value, everyone? 0. So we're going to do the same. So it's y equals negative 4 times 0 plus 3. What is negative 4 times 0? Nothing. We're left with 3. Very good. And the last one, y equals negative 4 times 1 plus 3. What is negative 4 times 1? Negative 4 plus 3 is negative 1. That goes right there. Now that we have our values, let's plot this. Let's see. Negative 1, I'm going to start with this one. Negative 1, 7. Negative 1, 7 up here. Okay? 0, this one, 0, 3. 0, 3. Last one. 1, negative 1. 1, negative 1. Okay? Next. Are we done? No, it says, why do you not connect the points on the graph? Talk it over there. Why don't we connect the points? Denise, why don't we connect the points? Because no. Because why? Help her out, please. Garrett. Why not? Because it doesn't include, let's just write this, all real numbers. For what? For the domain. So look, what is the domain that they give us? Negative 1, 0, and 1. They're saying only specifically for those 3 points. So check this out. Look up, please. Look up. So if they said this, use the domain from about negative 2 to 2. What does that mean? That we're going to substitute what values in here? Negative 2, what else? Okay, yes. But the domain also includes what? Look at this. From here to here, what other numbers does it include? How about negative, okay, we start at negative 2. How about negative 1.999999999? How about negative 1.8? How about negative 1.8999, and so on and so forth? This is what that means, that everything from here to here, including all the points in between. This is just saying that only these 3 points. Yes? Now you connect them. Did everybody hear that? Let's see, what did she say? Esteban, since she said yes. Very good. She said, if it only said graph the function, what are they telling us? If they tell us graph the function and they don't give us a domain, so therefore we use what? All real numbers, right? So we can use negative 2, negative 1, 0, 1, 2, connect them, and with the arrows that indicate that it keeps going for all real numbers. Okay, let's move on. Let's go to number 31. It says, a cup is filled with 4 ounces of iced tea. Every 3 minutes, 3 ounces of tea are sipped out of the cup. Write a function that shows the amount of iced tea in the cup after t seconds. After t seconds. All right. So let's cube this. Let's see. Cubed. circle important numbers. Important numbers here are filled with 48 ounces. Also, bless you, every minute. 3 ounces sipped out. Okay. Underline the question or questions. Write a function that shows the amount of iced tea in the cup after t seconds. And how long will it take for it to empty out? Okay. So, what are we talking about here? 1 cup? Oh, we're still not done. Let's box important information. They're talking about only 1 cup. What else? Sipped out. That's important. And the other one is every minute is important also. Okay. And exclude anything else, and let's draw our table. So 1 cup. Here it is. All right. Let's start off with the cup. Let's see what it has. How much is in the cup, everyone? Nate. 48 ounces. I'm serious. As we were, here we go. So we started with what? 48 ounces. What else does it say? Every minute, 3 ounces of tea are sipped out. Every minute, 3 ounces of tea are sipped out. What does sipped out mean? Take away 3 ounces every minute. But do we know how many total minutes? No. And what variable did they tell us to use for the this was in seconds. Okay. So at the end we just multiply times what? 60. All right. So every minute. No, I think this is yeah. Let's change this one to minute. Minute. Yeah, I made a typo on that one. So every minute and t, and that's also not gonna. Yeah, the t per time. So that's in t minutes. Okay, there it is. And that's gonna give us our total equation in t terms. So if it's a function, how can we write here? F of what? F of t. So let's write it out. F of t equals negative 3t plus 48. How long will it take the cup to empty? So let's see. So instead of f of t, we're going to write what? 0 equals negative 3t plus 48. And let's solve for t, yes? What do I do from there, everyone? Minus 48 minus 48. We're left with negative 48 equals negative 3t. And what is our last step? Divide by negative 3, divide by negative 3. You okay, Nate, over there? 16 equals t. Okay. So, let's answer the question. How long will it take for the cup to empty, everyone?
16 minutes.
So, right, 16 minutes for the cup to be empty. Oh, empty. 10Q. Empty of T. All right. Number 30. It says, Mike wrote the sequence 260, 230, 200, 170. Now this one's very similar to the other one, but this one says what kind of rule? Explicit. This is a little bit different. So here we go. First, for this one, look up please. We need an explicit rule. So first things first, we have 1 2, 3, 4 terms, and we need what? 5, 6, and 7. Yes? All right. So, first things first, to write an explicit rule, look up please, we need to write it in f of n terms. So I'm going to write f of n equals, look up please, the first thing that we need is the first term. What is our first term? Everyone? 260. That is correct. Minus. Everybody ready? F of n minus 1. Let's see, minus 30, I'm sorry. Yes, minus 30, f of n minus 1. Minus 30, f of n minus 1. And why minus 30? Let's see. So this is first term. And this is what? The pattern, right? What's happening from here to here, from here to here, from here to here? Subtracting 30. So let's see. Let's see if it works to find our next 3 terms. So this is what I want you to do for the next 3 terms. What is the next number that we're going to substitute? F of 5. So f of 5 equals 260 minus 30 times f of 5 minus 1. No. I made a mistake. I'm sorry. Sorry. There it is. Nice. There it is. Without the f of n minus 1. There it is. Yeah, because this is not a recursive. This is a explicit. So here we go. F of 5 equals 260 minus 30 times, what is 5 minus 1? 4. So f of 5 equals 260 minus 120. So what is f of 5? 140. That's our first term, or our 5th term. 140. Let's see if it worked. Look up, please. Let's see. Is it going by 30s? Yes? So is the next number up 140? Yes, it worked. So let's do that again. So now for f of what? 6. So this is pretty straightforward. F of 6 equals 260 times, minus 30 times minus 30 times 6 minus 1. F of 6 equals 260 minus 30 times 5. F of 6 equals 260 minus 150. And what does that leave us? F of 6 equals 110. 110. Oh. Yes? If you make a recursive, yeah, it would. So this is 0. Okay. And do the last one by yourself, f of 7, see what you get, see if it works. Did it work with the same process? Yes. So the last part was f of 7 equals 260 minus 30 times 7 minus 1. F of 7 equals 260 minus 30 times 6. F of 7 equals 260 minus 180. F of 7 equals 80. And that goes right there. Hands if you got that. Okay, good. Be nice.
Wait, I got 180.
Yeah, minus 180. Take away from 260.
Oh, yeah.
Huh? I know. Go to number 29. Here we go. This one is easy. Look up, please. A sequence has the explicit rule f of n equals n squared plus 1. Find the next three terms. So when you get to this one, and it says what? Explicit rule. This is what you're going to do. You're going to write a table. You're going to write n, f of n. And the first value is 1. The second one is 2. And the third one is 3. Because they want what? The first three terms. You guys remember these? These are very straightforward. So we're going to write what? F of 1 equals, instead of n, what do I write? 1 squared plus 1. F of 1 is, what is 1 squared? 1 plus 1 is 2. So f of 1 is 2. All right. Go to the next one. What is the next value? 2. F of 2 equals 2 squared plus 1. F of 2 equals, what is 2 squared? 4 plus 1. What is 4 plus 1? 5. All right. And the last value, 3. F of 3 equals 3 squared plus 1. F of 3 is 9 plus 1, which is 10. That goes right there, and we'll stop right there. Yeah? So that's up to 29. So tomorrow we'll continue. I'm going to upload this right now when we're done. Okay? All of this and all the no, not the whole study guide. We already did numbers 40 through 29. Yes? Because it includes the ones that we did in the warm-up. Maybe. All right. Just go over the ones that you might have questions. See if you can find them in your notes and help yourself. Yeah. I'm going to post this. Bye.